Hey everybody, we are going to talk about zeros and multiplicity. Maybe I'll add on here in polynomial functions. So I'm sure you remember that zeros just refer to solutions or roots. This kind of maybe even sometimes referred to as factors. Multiplicity is a term that we'll get to today. So looking at this function, f of x equals negative 5x to the power 4 plus 7x cubed minus 2x squared plus 4x minus 1. The one thing I really want to focus on this function rule first is every polynomial function has a degree. So the degree really just refers to what is the value of the largest exponent, which in looking at our function rule, we can see very clearly that the largest exponent here is 4. So our degree of this polynomial, the degree of this polynomial is 4. This is a 4th degree polynomial. So that is important for this reason, finding zeros. So if a polynomial is in the 4th degree, that means it has 4 total solutions, or zeros, or roots. Keep that in mind as we work through a couple of these examples here. The degree of the polynomial determines how many solutions there are. Now, the degree tells you how many zeros or how many solutions there are, and then multiplicity tells you how often that solution occurs. So this is all well and good. Just wanted to show you the degree. Now, here's a new function. I'll just call this one g of x, and we'll sketch a graph of this one. G of x equals, so let's do x plus 3 times x plus 1 squared times x minus 4. All right, so hey, let me, like I said, sketch a graph of this. Maybe I'll just do it right here. I'm not going to spend too much time on this. Okay. So to sketch a graph, this function is not in standard form like this. This is in factored form. So finding the zeros is going to be very, very easy to do. We know that x plus 3 is a factor, so I could set it equal to 0 and find my solution. So I know I have a solution at x equals negative 3. I could do the same thing with this factor. X plus 1 equals 0, so x equals negative 1. Now, this gets really important to keep track of the exponents. This x plus 1 factor is actually happening 2 times. X plus 1 times x plus 1 just got simplified and rewritten as x plus 1 squared. So we also have another solution at negative 1. And then this last solution, x minus 4 equals 0. So that would mean that x equals 4, because 4 minus 4 equals 0. X equals 4. Okay, so we know that we're going to cross this x-axis at negative 3. We know something's going to happen at negative 1. And we know that something is going to happen at positive 4. 1, 2, 3, 4. Okay, so a couple things to keep track of. I already mentioned this once, but multiplicity refers to how often the solution's occurring. So like this value of negative 3, the solution, that has a multiplicity of 1. That solution occurs exactly 1 time. The negative 1, that happened twice. That means we have a multiplicity. That means we have a multiplicity of 2. Since it happened twice, the multiplicity is 2. And this last solution, the 4, I'll write it down just for good measure. The x equals 4, we have a multiplicity of 1. Okay. Let me graph this now. So we know that we're going to cross at 4. I know that the function is going to have a positive end behavior because the leading coefficient here is positive. There's no negative sign. So I know it's going to increase at the very end. Goes like this. Now, one thing we really need to keep track of, we know that this solution happens twice. So how your function behaves when that happens, it doesn't actually go through the x-axis. It gets very close to it and then just bounces off. When you see a function bounce off of the x-axis, that's telling you there's a multiplicity of an even number. In this case, it's just 2. We start to go back down, and then we have to curve back up to get through this -3 solution. Since the multiplicity there is just 1, we're going to pass straight through it, like that. So of course, by no means a perfect sketch, but hopefully it gives you the idea of where the zeros are, how to locate them, and what it means when the multiplicity is 2. Again, when the multiplicity is 2, your function is going to bounce off of the x-axis. It's not going to go through it. Okay, so let's go through one more example. I'm just going to graph this one. Like that, and then like that. Our x-axis, we got our y-axis. Okay, so again, I'm just going to sketch a polynomial, and we'll talk about the degree, the solutions, multiplicity. Okay, let's do it. So we'll have this function just come up from the bottom here, pass through the x-axis right there. We're going to have it do this, bounce off, come back up, and we'll do this weird kind of shift right there. Keep going on up. Okay, so this one is this function, I'll just tell you, this is a 5th degree polynomial. That's important because it tells you how many total solutions there are. We know that if it's a 5th degree polynomial, there are going to be 5 total solutions. Now, reading the graph, let's figure out how many real solutions we have. We know we have some real solutions. We know that x is equal to, so we have a real solution right here. It passes through the x-axis at this point. So we have a real solution at, looks like that would be around -1, -2, -3, -4, maybe like -4.2. And we know we have another real solution at this value. It looks like that's at around -0.5. Now remember, if you ever bounce off the x-axis like that, there's actually more than just one solution there. There's 2. When we bounce off the x-axis like that, we have 2 solutions. Which means there is a multiplicity of 2. Okay, so now that's it for our real solutions. We know that we have 3 real solutions, but there has to be 5 total solutions since it's a 5th degree polynomial. We kind of have this weird direction change right here. We know we have 3 real solutions. We're trying to make 5 altogether. So all you would have to say now is there are 2 imaginary solutions. There are 2 imaginary solutions. The total number of real and imaginary solutions have to add up to make the degree of your polynomial. So since I have 3 real solutions, I can add 2 imaginary solutions, and that will give me the 5 total solutions that I was looking for. That's really does it for what we're doing today. Just trying to find roots from the graph and making sure that the number of roots matches the degree of the polynomial. And then another kind of key point from today was this concept of multiplicity. If the function bounces off of the x-axis, there is more than one solution there. So this value of -0.5 has a multiplicity of 2. It actually happened twice. All right, so we'll definitely talk more about this in class. Thanks for watching. See you guys there. Bye-bye.